Hello, in this video we are going to dive into the unit circle and learn how it applies to our different trigonometric ratios. So, to begin, we first must develop our understanding of the unit circle. The equation of the unit circle is x squared plus y squared equals 1. This is the standard or the parent function of a circle. It is on the coordinate plane. We're talking about graphing, parent functions and graphing, of course it's on the coordinate plane. And it has a radius of 1 unit. So let's see what this looks like. Here we have a coordinate plane. This is our circle, and its radius is 1 unit all the way around the circle, hence it's a unit circle. Now let's determine how our trigonometric functions relate to this unit circle. So once again, here's our unit circle, and here's our radius of 1. At any point, we can rotate the radius and stop it, and for any degree. So in this case, we went 45 degrees. And here we have this point, and this point actually has an ordered pair, x comma y. But how can we determine what x and y are? Well, we can use our trig ratios by dropping a vertical line and creating a triangle, and using our trig ratios that we learned in geometry and reviewed in Algebra 2 Trig, we can establish our x and y. So our x is our x-axis, of course. I don't know why that took me a second to think of that. And our y is the line we drop down. And our hypotenuse is 1 because it's also our radius. So let's dive into our trig ratios. We know that sine is the opposite over hypotenuse. And in this case, opposite of theta is y, and our hypotenuse is 1. Therefore, sine is y. Cosine is adjacent over hypotenuse. So that's x over 1 because our hypotenuse is still 1 because our radius has not changed. Therefore, cosine is simply x. So anytime that we see an ordered pair in regards to the unit circle, the x value is our cosine value and the y value is our sine value. I'm going to say that again. Anytime we see an ordered pair with our unit circle, the x correlates directly to cosine and y correlates directly to sine. Tangent is sine over cosine. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is cosine over sine. So cosecant, secant, and cotangent are reciprocal trig functions. Once you find your first 3 trig functions, sine, cosine, and tangent, you can simply find the reciprocal, meaning you flip them, to find your remaining trig functions, cosecant, secant, and cotangent. One thing to be careful of, do not pair cosecant and cosine together. The cos cannot go together. Cosecant pairs with sine, secant pairs with cosine, and then cotangent pairs with tangent. But so many times we run into the mistake where people naturally pair cosine with cosecant and sine with secant. However, they are mismatched. The s's don't match up and the c's don't match up. Sine starts with an s and it pairs with cosecant, which starts with a c. Cosine starts with a C, and it pairs with secant, which starts with an S. So let's start finding this cosine and sine value. So first, sine of 45 equals y. We can plug that into our trig function, into our calculator, and we're going to get square root of 2 over 2. Cosine of 45 equals x. Plug in cosine of 45 in your calculator. You're still going to get square root of 2 over 2. So now instead of x, y, we know that x and y are square root of 2 over 2, comma square root of 2 over 2. So let's dive into an example. Evaluate all 6 trigonometric functions using the unit circle. Here we have a unit circle. Its radius is 1, and we want to open it up to this point right here. This point is negative 12 over 13, comma 5 over 13. So we want to use this point, knowing that it's on the unit circle, to find all 6 trig functions. Knowing that it's on the unit circle, we know that it has a radius of 1. We know that our sine value correlates directly to our y, and our cosine value correlates directly to our x. Just like cosine, x and y are in ordered pairs in alphabetical order, cosine and sine are in alphabetical order. C comes before S, so cosine comes first in our ordered pair. So looking at our ordered pair, cosine is negative 12 over 13 and sine is 5 over 13. Now we know that tangent is sine over cosine. So that's going to be 5 over 13 over negative 12 over 13. Simplifying that using our calculator or our knowledge of fractions, that simplifies to negative 5 over 12. Now, secant pairs with cosine, and secant is the reciprocal of cosine. Therefore, secant in this case is negative 13 over 12. Cosecant pairs with sine, and it's the reciprocal, so in this case it's 13 over 5. And cotangent is the reciprocal of tangent, so it's negative 12 over 5. So let's look at the unit circle a little bit more. Here is a completely filled out standard unit circle. If you're going to progress to higher math classes in college, I strongly suggest memorizing this. But let's just establish some patterns or identify some patterns. First, at the 45-degree angle, we had already found that this was the square root of 2 over 2, comma square root of 2 over 2. Let's look here at 135 degrees. We see that we still see 2 square root of 2's over 2's. However, the only thing that has changed is our x value. Well, that's because we're on the negative side of the x-axis. Then down here at 225 degrees, we still see square root of 2 over 2, but this time both of them are negative. Well, that's because we're in quadrant 3 and we're with the negative x-axis and the negative y-axis. And lastly, we see square root of 2 over 2 at 315 degrees, but this time only the y-coordinate is negative because we're on the positive x-axis and the negative y-axis. We can notice the same pattern with all of our unit circle values that are closest to the x-axis. Notice in quadrant 1, square root of 3 over 2 and 1/2 are both positive. In quadrant 2, only the x value is negative, so square root of 3 over 2 is negative. In quadrant 3, both are negative because we're with the negative x-axis and the negative y-axis. And in quadrant 4, only our y is negative, negative 1/2. We can see the same thing with all of our coordinates that are closest to the y-axis. And you can see where in quadrant 2, the x value is negative. In quadrant 3, both values are negative. And in quadrant 4, where only the y value is negative. This is where I really, well, it's one of my favorite sayings. Y'all probably don't think it's that cool. Comes into play. All students take calculus. All means all trig functions are positive. Sine, cosine, tangent, cotangent, secant, cosecant. I don't know why I said this out of order. In quadrant 2, only sine is positive. Sine and its reciprocal, so sine and cosecant are positive. In quadrant 3, only tangent is positive, so tangent and cotangent. And in quadrant 4, cosine is positive, so cosine and secant. So if we were looking at quadrant 2 and we know that sine and cosecant are positive, then that means that cosine, tangent, secant, and cotangent are all negative. So that's just a way to self-check your answers before you submit your work. All right, our last example, we're going to evaluate all 6 trig functions for 4 pi over 3. Looking at the unit circle, we see 4 pi over 3 down here in quadrant 3. And we see that the ordered pair is negative 1/2, comma negative square root of 3 over 2. So we're going to take all that away because that was way too busy, and we're going to make it on our own unit circle. So here we are, and we're going to use this information to find all 6 trig functions. We know that it's cosine, comma sine. Cosine is our x value, so in this case, cosine is negative 1/2. Sine is our y value, so sine is the square root of 3 over 2. Tangent is sine over cosine, which is the square root of 3 over 2 over negative 1/2. Using our calculators, that simplifies to the negative square root of 3. Or you could use your fraction rules, and you would notice that keep, change, flip, and your 2's go away. Oh, I shouldn't have had a negative by that square root of 3 on the top. I mistyped that. Okay, oh well. Negative square root of 3 over 2 should have been a positive square root of 3 over 2. Secant correlates directly to cosine, so now we have negative 2 over 1, which simplifies to negative 2. Cosecant correlates directly with sine, so that's the 2 over the square root of 3, but we do not want radicals in the denominators, so we have to rationalize it, and we get 2 square root of 3 over 3. And cotangent is going to be the reciprocal of the square root of 3 over 1, which is going to simplify to the negative square root of 3 over 3. I typed that wrong. That's supposed to be 1 over the square root of 3, and that's going to simplify to the negative square root of 3 over 3. Man, I made 2 mistakes on that slide. Sorry about that. But you just use, if you know that cosine is x and sine is y, then you can establish all other 6 trig ratios.